Good morning, guys. Happy Monday. I know a lot of you guys are taking the AP Bio test today, so good luck on that, and good luck on all the AP exams that you've been taking, that you will be taking this week. If you're a little low or slow on your assignments getting them in, that's fine. As long as you get them in within a few days, that should be okay. So we're going to do a specific type of limit today. It's called the difference quotient. And the reason why it's an essential calculus limit is because it really is going to help us to find the slope of the tangent line, which is in fact the derivative, which is the most basic calculus concept that we use, and the most fundamental calculus concept that we use. All right, so we're just going to go through two examples, and the assignment's pretty short for today, but you just need to make sure that you show your work. There's a lot of algebra in simplifying functions, and what you'll find in calculus is that there is a lot of algebra, rewriting functions, using any of the techniques that you've learned before entering a calculus course. So we're going to take a look at this. So given this function, f of x equals x squared minus 1, we're going to evaluate this limit. So this limit is the difference quotient, and we'll talk more about what this limit finds on Wednesday when we start to introduce the tangent line. But for today, we're just going to focus on the evaluation of this limit, so just the math that goes with it. So we're going to do the limit as h goes to 0 of f of 3 plus h minus f of 3. So this is using our function notation, so you have to be given a function, which in this case was right here, all over h. Now you'll see if you tried to do direct substitution right away, replace h with 0, you'd get f of 3 minus f of 3, which would be 0 over 0, and that's one of our indeterminate forms. So that means that the limit could still exist. So what we're going to do is we're going to simplify f of 3 plus h and f of 3, and then substitute them into this fraction. So for f of 3 plus h, since this is our function f of x, this is just telling us to replace all of our x's with 3 plus h. So on this side, if we replace x with 3 plus h, we get 3 plus h quantity squared minus 1. And then we just want to simplify that. So we're going to square this binomial. Make sure you FOIL it out. You're going to get 9 plus 6h plus h squared. And then we have the minus 1 here at the end. And then we can just combine like terms. The 9 minus 1 will be 8. And then if we want to, we can write this in standard form. So f of 3 plus h will simplify to be h squared plus 6h plus 8. And then we also need to evaluate f of 3. So f of 3, we're going to replace 3 in for x, or replace x with 3 here. So that gives us 3 squared minus 1, which is 9 minus 1, which is 8. So now that we have these two, one value and one function, we're going to replace them here, right, in this difference quotient, and then hopefully simplify and evaluate the limit. So that's going to give us the limit as h goes to 0 of f of 3 plus h, which we just did here, minus f of 3. And you want to use parentheses just because of the minus sign here, making sure that it gets distributed to any terms that are in this second term here. So now if we want to, we can distribute the negative just to this 8 and combine like terms. The 8 minus 8 will cancel, and that will leave us with just the h squared plus 6h. Now, even at this point, if you try to do direct substitution, if you try to replace h with 0, you're still going to get 0 over 0. So now we're going to use one of our techniques, and in this one, we can use factoring. In the top, we can factor out an h to get h times h plus 6, and now we can cancel the common factor. This is what you're always looking for when you get 0 over 0. Once something cancels, when you're allowed to cancel, all right, we should be able to do direct substitution after that. So the h's cancel, we're left with h plus 6. Now we can do our direct substitution, replace h with 0, and our final answer to this limit that we started with is 6. But remember, with this limit, we have to be using this function. So whenever you're doing this difference quotient, right, with f of, you have to be given some function of f. And sometimes not f, it could be g of x, and they could use g here, or they'll probably avoid h of x just because there's already an h here. All right. So now let's look at a second example where we're not actually using a value here. We're just going to be using x. So now for this one, we've got a new function. F of x is going to be x squared plus 9x. And now we're going to evaluate this difference quotient. All right. So we've got f of x plus h minus f of x all over h, and we're still going to do the limit as h goes to 0. Okay, make sure you make a note of that. This is h, not x. But you can definitely see if you replace your h's with 0 in the very beginning, you'll get f of x minus f of x, which would be 0 over 0. So that means we have to be able to simplify. So we're going to do the same thing we did in the last one. We're going to evaluate f of x plus h off to the side and f of x, and then substitute them in. So since this is our function, f of x plus h, we're going to replace x with x plus h here and here. Right. And then we're going to distribute and combine like terms. So here we have to FOIL because we have our binomial squared, which would give us x squared plus 2xh plus h squared. And then here we just have to distribute the 9. All right, so we've got the x squared plus 2xh plus h squared, and then plus 9x plus 9h. And at this point, there's no like terms to combine, so this is actually going to be it. All right, so this is what it simplifies to be. And then f of x is just our original function, x squared plus 9x. Again, no like terms to combine, so we're going to leave it like that. So now we're going to replace f of x plus h and f of x with these two functions that we found in our difference quotient. So we have the limit as h goes to 0. This is the function that we found for f of x plus h minus, okay, so we have our minus here. And again, this is why the parentheses have to be here. X squared plus 9x, and then all over h. Again, in any of these steps, if you had replaced h with 0, you'd still be getting 0 over 0. So now we want to distribute, combine like terms, and hopefully be able to evaluate the limit. So when we distribute this minus, we get minus x squared minus 9x. And you'll see that they'll cancel. This x squared minus this x squared will be 0. 9x here minus 9x here will be 0. So we're going to be left with just these three terms, 2xh plus h squared plus 9h, all over h. But now that we've done that, we can now factor because there is a GCF in our numerator. We can factor out an h from all three terms, which will give us 2x plus h plus 9, and now the h will cancel. You can only cancel, remember, when you're in factored form. All right, so over here, you're not allowed to cancel out just this h, all right, because the top is not factored. You have to make sure the top is factored first, then you can cancel out the common factor. So that will give us the 2x plus h plus 9 once the h is canceled, and now we can do our direct substitution. Replace h with 0, and here we're actually left with a function, right, rather than a number, because our original limit, we were letting h go to 0, but since this was a function of x, it makes sense that our answer is going to be a function of x. And on Wednesday, we'll talk more about what this answer actually represents graphically when we start to talk about tangent lines and slope and first derivatives. All right, but for now, we're just going to worry about being able to evaluate this limit. Okay, so the homework assignment, I'll post it on Classroom in a Google Doc so that you have these problems. We're just going to do these 4 problems. And again, show all the work, just like I did for the last 2 examples. You should show what your f of x plus h is, what it simplifies to be, and then evaluating the limit. Okay, so there's only 4 questions. If you have any questions at all, send me an email.